This is Andrea Hendricks, and I want to talk to you about Section 4.1, the product rule and power rule for exponents. If you recall back in Chapter 1, we talked about the definition of an exponent and worked with it with just numerical expressions. In this section, we're going to study that further and talk about identifying bases in exponents, using the product rule for exponents, using the power rule, which is a to the m raised to the n, using another type of power rule, and a quotient rule, and then using the rules in combination. These rules are going to be designed so that you can have basically some shortcuts to simplify algebraic expressions that follow these types of patterns. So let's talk about recalling the definition of an exponent. If you recall something of the form a to the n, where n is a natural number, which just means that n is equal to 1, 2, 3, and so on. Remember that that means a is repeated by multiplication a total of n times. In this expression, a is called the base, and n is called the power or the exponent. Some key things that you need to be familiar with in this type of expression deal with negative signs. So let's talk about that for just a moment. Let's suppose we have something of the form negative 5 in parentheses squared. Well, by definition, our base is negative 5 because it's in parentheses and the exponent is outside of those parentheses, so it applies to it all. So that means to repeat the negative 5 by multiplication 2 times, which makes that a positive 25. Now let's change the problem ever so slightly and remove those parentheses. In this case, this is read the opposite of 5 squared. You can think of it as really a negative 1 times 5 squared. So the base of the exponent in this case is just the 5. So that means only the 5 repeats. The negative 1, or the opposite, stays. So we'd really have the opposite of 5 times 5, or the opposite of 25. So identifying the base is critical. The base, if there are no parentheses, is the number or expression immediately to the left of the variable. If there are parentheses, then the base is everything inside those parentheses. So a key thing to remember is that if you have the rule or the expression the opposite of a to the n, the base of that is just a. If you have negative a to the n, that base is negative a. Okay? Now, let's talk about some of the rules that we're going to learn with exponents. Let me move this rule down here for just a minute and I'll just explain it. Let's talk about something of this form. If I have 2 to the 5th times 2 squared. If I don't know any rules and all I'm doing is using the definition of the exponent, the 2 to the 5th means that 2 has to repeat by multiplication 5 times, right? That's 2 to the 5th. Then I have to multiply it by 2 squared, which is 2 more copies of the 2. So another way I can write that in exponential form is to observe that the 2 is repeating 1, 2, 3, 4, 5, 6, 7 times. So whenever you have a product of like bases, right, the bases here are 2. When you have a product of like bases, the rule is we can add their exponents. but the base has to stay the same because it's the 2 that is repeating 7 times. It is not the product of the bases that is repeating. A very common mistake here is to write that as 4 to the 7th, but that is incorrect. So this is where this product rule comes in. For any positive integers m and n, we have a to the m times a to the n, that is equal to a to the m plus n. Keep the same base, add the exponents. An example that I just did, very similar to that, except here's one with 6's, but the idea is the same. The base stays the same, we just add the exponents together. Okay? Now, what if we have something of the form x to the 4th times x? That is where we don't visibly see an exponent written. You have to understand then that the exponent is understood, right, to be 1. So if we're multiplying like bases, then we can have our base stays the same, and then we add 4 plus 1, which is x to the 5th. Okay. Now, a problem that you had in your homework, let me show you something like this. If you have a 4p to the 3rd times 4p squared, are the bases the same? Yes, the bases are 4p. So if we use this product rule, that says that we would have our base the same, which is 4p, it has to be in parentheses, raised to the 3 plus 2, which would be 5th power. If you omit the parentheses and write just 4p to the 5th, the exponent of 5 only applies to the p, not the 4, so the meaning has completely changed. So to get that correct, you have to put the base in parentheses. Okay? Now, we're going to introduce another rule in just a moment, but I want to show you some examples of this. Let's suppose that we have x squared raised to the 3rd power. Again, if we use the rule that we just talked about, which is the basic rule of the exponent, we would write this as x squared repeated 3 times. And then we can apply the rule that we just talked about that says if you're multiplying like bases, you can add the exponent. So 2 plus 2 plus 2 is 6. So that would be x to the 6th. So this brings about a rule that we can call the power rule. And the power rule suggests this, that for any positive integers m and n, if a to the m is raised to the nth power, we get a, write that bigger so you can see it, a to the m times n. Okay? So if we raise a power to a power by multiplying the exponents together. And again, notice that the base of the inside exponential expression stays the same. So this works with numerical values as well. Right? If I have 5 to the 2nd raised to the 4th, that would be 5 to the 2 times 4, which is 8. Okay, look how that compares to the rule we just talked about. If you have 5 squared times 5 to the 4th, that one would be 5 to the 6, because that's talking about how many copies of 5 do you have when you're multiplying the like bases. Okay. Let's talk about another property. Let me illustrate it as well. This deals with something of the form if you have 2x squared cubed. That is, you have a product inside raised to a power. Well, by the rule of the exponent, if this is our base, 2x squared, it has to repeat 3 times. And so we can regroup by the commutative property to put the numbers together and the variables together. And here we have 2 times 2 times 2. If you will, that's really 2 to the 3rd, right? X squared times x squared times x squared. I'm just putting in this intermediate step. That's really x squared cubed. Right, because now the 2 is repeating 3 times, the x squared is repeating 3 times. In the end, our final answer would be 8x to the 6th. So the rule that's going to apply here is that whatever's inside parentheses, if it is a product and it's raised to a power, that exponent has to apply to each of the factors inside. Okay, so this only works when you have a product to a power. So here's the rule. For any positive integer m, a times b to the mth power is a to the m, b to the m. So we raise a product to a power by raising each factor to the power. Okay. Now, there's one very similar to that for quotients. Hopefully you would agree that that's going to be the same thing, because a quotient is really multiplying by the reciprocal. So a over b to the m is also a to the m over b to the m, because if you think about it, the fraction a over b would repeat m times. So then to multiply fractions, you multiply the numerators, multiply the denominators, so a is repeating m times as well as the b is repeating m times. And here's an example. If you have 5 over 3 squared, that's really 5/3 times 5/3, which is, as I have written, 5 squared over 3 squared, which you could simply write as 25 over 9. Okay? So, we have several rules from this section that you need to be able to understand. If you have a to the m times a to the n, we add exponents. If you have a to the m raised to the n, we multiply exponents. If you have a product ab to the m, we can write that as a to the m times b to the m. If you have a quotient a over b to the m, that's the same thing as a to the m over b to the m. So let's talk about how we can use a combination of these rules to simplify algebraic expressions that involve exponents. So I'm going to choose the problems that are based from your exercise set in the textbook just to review these. Like number 34 on page 249 in your textbook says 10a to the 7th times negative 4a to the 3rd. So we have the coefficients that can be multiplied. We can write that as 10 times negative 4. And then a to the 7th can be multiplied by a to the 3rd because they're like bases. So this would really be a negative 40 times a to the 10th because we add the exponents there. What about something of the form number 51 on the same page is a negative 5 squared raised to the 6th power. When you see a problem like this, think of that as really a negative 1 times 5 squared to the 6th. So the 6th power is going to apply to the negative 1 as well as to the 5 squared. And you remember that if a negative number repeats an even number of times, it becomes positive. So negative 1 to the 6th is really a positive 1. And then 5 squared to the 6th, we multiply to get 5 to the 12th. So this is really the same thing as a positive 5 to the 12th. Now, when would it not be positive? If you look at number 53, it is a negative 8 to the 3rd raised to the 5th. And so this is again like a negative 1 times 8 to the 3rd raised to the 5th. So a negative 1 raised to an odd power is going to be a negative 1. 8 to the 3rd raised to the 5th, we multiply powers, get 8 to the 15th. So this is really the opposite of 8 to the 15th. So if the outer power is even, and you have a negative coefficient or negative expression inside, it's going to become positive. If the outer power is odd and a negative coefficient inside, the answer will be negative. Now, let's move on to number 68, which says 6y to the 5th times 6y to the 8th. A couple ways you can do this. I actually talked about one of these earlier. These are the same base. So you can just keep the base and add the exponents, right? 5 plus 8 would be 13. And then if you wanted to remove the exponents, you would have to apply the 6 to the 13th power and the y to the 13th power. Looking at number 71, 6x squared y to the 3rd raised to the 5th. So here, the exponent of 5 has to go to the coefficient. That's a common mistake, to forget to apply it to the coefficient. So you'd have 6 to the 5th, x squared to the 5th, but that's a power raised to a power, so we can multiply. Y cubed to the 5th, same thing, power to a power, we multiply. And that would be our answer. Now on the calculator you can find out what 6 to the 5th is if you need to simplify that. Let me do one more of these. Number 76 is 3x to the 4th y squared times z all to the 3rd times y z to the 4th raised to the 5th. So if you remember order of operations, we need to apply our exponents first, working in the parentheses. So the 3 in the first set of parentheses would apply to each of those factors. 3 to the 3rd, 3 times 3 times 3 is 27. X to the 4th to the 3rd is x to the 12th. Y squared to the 3rd is y to the 6th. Z raised to the 3rd is just z to the 3rd. Now that's multiplied by the second expression, all raised to the 5th power. So y raised to the 5th is y to the 5th, right? We're multiplying, that's an understood 1 times 5. Then z would be raised to the 20th power. And then we're not done because we have like bases. So we can combine these like bases, since we're multiplying like bases. We can add their exponents. So this expression would be 27x to the 12th, y to the 6 plus 5, which is 11, and z to the 23. So if you have any problems with this material, please contact me and I'll be glad to help you out. I guess I should do one other type before I finish. There are some problems in here that ask you to find the area or the volume, and they give you an expression that's a variable expression for the length or the width. So let me talk about that. Number 83 on page 250 is to find the area of this rectangle, where they tell you that the length of it is 4x cubed, the width is 3x squared. So to find the area is length times width. So that's going to be 4x cubed times 3x squared. So that is multiplying like basis, so we can add the exponents, so that would be 12x to the 5th power. Again, don't make the mistake of multiplying the powers. The last problem is to find the volume. So number 87, they give you a box. And you have 5x squared for all of the dimensions. The length, width, and height. Volume is length times width times height. So if you multiply 5x squared times itself 3 times. Oops. So you'd have 5 times 5 times 5, 25 times 5 or 125. X squared times x squared times x squared, we can add the exponents to get x to the 6th. Okay? And that will conclude these problems. So again, if you have any questions, please don't hesitate to contact me. Thank you. Bye-bye.